Alors, je vais maintenant switcher et passer à l'anglais pour présenter notre conférencier d'aujourd'hui. Alors, welcome everybody to our series of webinars that are a shared initiative of EcotoQ, the network of Quebec ecotoxicologists, and Chapitre Saint-Laurent, that is a branch of CTAC. So today's speaker is Kevin Elliott, who is a professor of philosophy at Michigan State University. So we're really today leaving our traditional ecotoxicology narrow areas of seminar to address a topic that concerns every scientist. And he will actually be talking to us about open science, open publications, data repositories, and several guidelines that are related to open science. You've probably seen in the poster that we've advertised his presentation that is also that our speaker today is also an author of a number of books, including one that is of high appeal to us. It's called "Is a Little Pollution Good for You?" Talking about concepts like hormesis, for example. So I encourage you to check that out as well. And so how it will work is that our speaker will be giving us a brief, well, not a brief, a detailed presentation, about 35 to 40 minutes. And when he's done, we will have an open question period. If you now can open your chat box, you will be able to see that there are that it's a place where you can actually ask questions. So you will actually see a welcome word from Isbat, who is our coordinator. We will also have Lou Paris, who will be joining us in a couple of minutes. And so if you want to ask questions during the conversation, during the presentation, you can always write them to everybody in the chat box, or you can also address them directly to me or to Lou Paris or to our speaker, Kevin, today. And so after that, we will, after his presentation, we will be able to discuss any aspect that you could be interested in discussing with our speaker today. So I will encourage you to turn off your microphone if it's not already done. And in the meantime, I will let our speaker start his presentation. So Kevin, thank you very much for accepting to give us a webinar today. So it's all yours.
Okay, thank you so much. And you know, I don't know how you all typically operate. If you want to ask questions as I'm presenting, feel free. But I probably won't do a very good job of watching the chat while I'm presenting. So anyway,
actually, Kevin, just to make sure, I propose that people can write their questions during your talk, not to forget them. But please don't watch the chat and get disturbed, so we'll review them afterwards, okay?
Beautiful. Okay,
so,
sounds good. Well, thank you. So what I'd like to do is to offer an overview of the open science movement today. And then you'll see that I also want to offer my own particular perspectives on this. And so I appreciate you all inviting me. I know you probably don't typically have philosophers presenting for you. My background, just to give you a little bit of a sense of where I'm coming from. I did my undergraduate degree in chemistry, but as I did various research projects as an undergrad, I realized I have to confess to you all as scientists, I didn't really enjoy the research. In particular, I wasn't very good at it. Loved, thinking about the sciences, understanding scientific developments. And so I ended up then doing my PhD in the history of science and the philosophy of science, and focusing especially on the philosophy. And so I spent some time in philosophy departments in my career at Michigan State University for the past 6 or 7 years. I've been in a very interdisciplinary position. So you'll see I'm in Lyman Briggs College, which is a residential college there, focusing on the education of undergraduate natural science majors, but all the students take several courses in the philosophy of science or the history of science or the sociology of science. So we try to train these scientists with a really broad perspective to go on in their future careers. And then I also am partly appointed in the Department of Fisheries and Wildlife, where I tend to teach courses related to environmental ethics. So I love these kinds of interdisciplinary appointments, and I love working with scientists on interdisciplinary projects. So what I'd like to do in the presentation is to basically focus on 4 things. I'd like to talk first, just give an overview of the objectives of the open science movement, and then highlight just an array of initiatives. And I think probably you all are very familiar with a lot of these things. So, bear with me if some of this you're extremely familiar with. I'm hoping that there are at least some aspects of the talk that will move into ideas that are interesting and valuable. And feel free to, sort of correct me or challenge me ultimately in the answer section. I'd love to learn from you. Then I'll be discussing some of the barriers I think that we face in trying to implement open science. And then where I especially bring in my own perspectives is in the opportunities, how we can move forward. And you'll see that I'm especially excited about ways to make open science more relevant to a broad array of communities and stakeholders, even beyond the scientific community. So just to be sure we're all on the same page, I have a quotation here from a report from the National Academy of Sciences in the US from a couple of years ago, where they said open science, is focused on the free availability and usability of scholarly publications, as well as the data associated with scholarly research and the methodologies and code or algorithms used to generate the data. And I'm actually going to extend this a little bit further. I think that there are aspects of the open science movement that can even go beyond this, but we'll see as the talk goes on where I'm headed. So first, just to highlight, why are scientists, interested in open science, and why is the broader society interested in this? Well, I think one of the first justifications that we, tend to hear is that this can help to accelerate scientific discovery and innovation. We can have results being spread faster through open science. And scientists can get access to more data sets and larger data sets. They can bring different data sets together. I'm collaborating at MSU with some environmental scientists doing really large scale limnology, sort of looking at lakes across really large scales. And open science is incredibly helpful for them to have data sets that they can work with. And then open science can help advance collaboration, so you can work more successfully with others. And, we've all been, hearing in the news over the past year the ways in which, trying to respond to COVID-19 has, sort of pushed open science sorts of approaches forward. Lots of, putting information in online repositories and sharing information that can help us, address this more quickly. So we really see that objective in action. Then a second objective that I think is important is aiming for scientific quality. So, I'm sure you all hear about worries, especially in the biomedical sciences and to some extent in the social sciences like psychology. There's been a lot of concern about the idea of a reproducibility crisis, that you have a lot of papers being published that people can't reproduce. And, when they try to sort of look across a range of papers to see what percentage have been reproduced, there have been some high profile papers saying a surprisingly large percentage can't be reproduced. And so the thought is, if the data and the methods underlying papers are more available, well, people can be better able to determine if studies can be reproduced, and perhaps people will be more careful and do more reproducible science if they have to operate in a more open way. And then as toxicologists, I'm sure you're familiar with all the concerns in some areas of science about the potential for conflicts of interest or biases affecting research. And so the thought is, well, if the underlying data and methods are made more openly available, well, then we can check to make sure that this isn't a problem. And just to give an example in a different area of science where it's not so close to home, there was a really interesting case a few years back where a faculty member at the Cleveland Clinic, Steve Nissen, was able to access data from the safety studies of a diabetes drug, rosiglitazone. And because this data they were available, he was able to identify concerns about heart problems associated with the drug. And what's especially striking here is these data were available to the company producing the drug, and they were available to the US Food and Drug Administration, but these worries really hadn't been raised. And so it illustrates how having data available can enable other scientists to highlight concerns. But what's striking is the reason these data were available to him was because the company had gotten in trouble previously for not acknowledging safety problems with their drugs. And so because of a court case, they had to make a lot of data for their drugs available. But in general, this wouldn't be possible. And so we may be missing out on important information as a result. Then another objective, a goal pushing open science forward, is the fact that the public would like to have more access to information in a lot of cases. And this was especially highlighted in a nice report from back in 2012 that the British Royal Society produced on open science. And they really emphasized a lot this concern for citizens to have information. And they say, there's a lot of demand when you're dealing with regulatory areas of science for broader publics to be able to scrutinize the evidence that underpins decisions, regulations, and so on. And I think this is very relevant in the case of toxicology. And then lastly, another consideration that may not be discussed quite as much, but that I've written about a little bit with some collaborators, is the idea that as we try to develop a more equitable and inclusive scientific community, by making data more widely and openly available, this can provide opportunities for scientists who may be at institutions where they don't have as much money for generating big data sets of their own. But if data are made available, well, then it can allow a broader range of scientists to participate in scientific activities. So I think that's another consideration that's worth keeping in mind. So those are some of the big goals. I'm sure there may be others, but those are ones that I would highlight for why we're trying to pursue open science. So here I get into the initiatives, which is where a lot of you could probably do a better job in the talk than I could. But I just want to highlight the range of activities that we can be thinking about here. And I'm sorry for the poor quality of this slide, but I like it. I pulled it from this project in the EU. That shows how we're not just talking about a few activities like making publications openly accessible or making data available, but there are a whole range of activities and they can connect and relate to each other. So let me go through just a few of these. So first, perhaps the most obvious initiative that comes to mind with open science is making publications available, beyond paywalls, so that people don't have to either have access to a university library or be in a corporation that has lots of money to get access to publications. And so, about 20 years ago or so, we started seeing these initiatives with these journals, whether it was through the Public Library of Science or Biomed Central or others, to shift the publishing model so that authors could be paying a fee in advance and their papers would be available for free to anyone. And this is now, of course, as you all know, accelerated so that lots of other journals that aren't completely open access provide the opportunity. And we're seeing various initiatives like Plan S, that was especially pushed out of the European Union to say, if publications are arising from publicly funded research, well, then they ought to be made openly accessible. And so journals need to find ways to make this possible. So that's one significant initiative. But then, of course, as I was kind of noting earlier in talking about COVID-19, even before papers go through peer review and are published, there's a trend for preprint servers where papers can be made available very quickly. And so we're seeing various archives like the bioRxiv. This has been going on for a long time in areas like physics and astronomy. There's a medRxiv now. And this has been in the news because there was just such a flood of preprints that have been produced about COVID-19. And this talk is based on when I gave last spring for the CTAC Europe. And one of the things that got the most discussion after the talk was the pros and cons of these preprint servers, because of course, there's not the peer review process. And so there's the worry that there can be, information in these preprints that may not be super reliable. We know that the peer review process doesn't always solve these problems either, but there's at least more checks and balances. And so thinking about how we can develop these preprint servers to glean the benefits, but to address some of the worries, I think is something important we need to be thinking about. And then, of course, we also think about repositories and requirements for making data and code and materials available. And so, this is a registry with a whole bunch of different data repositories where people can make their data available. Thinking historically, one of the first repositories in the biological sciences, of course, was GenBank, where coming out of the Human Genome Project, there was a real push to make gene sequences available, so other researchers can make use of them. In the social sciences, the ICPSR is a very influential data repository. And I'm sure you all are actually much more likely to be aware of using GitHub than I am, but of course, it's an influential site now for code associated with one's scientific work. And now, both journals and funding agencies and even, legislation is starting to push toward making data available. So, of course, in the toxicology context, there's been a lot of discussion recently about Europe requiring that the safety studies done for regulatory purposes, that data should be made available. And so we're seeing this, becoming more and more of a prominent issue. But of course, it's not enough, and this is a theme I'm going to talk about later. It's not enough just with open science to just kind of drop information out there. One needs to have some sort of structure so that those who are wanting to use this information can actually make use of it. And so there are, principles and guidelines, of course, for things like organizing data. And I'm not going to get into this in detail, but I would just point out this is one paper that lays out these FAIR guidelines that have been fairly influential for focusing on the kind of metadata that need to be provided with the data in order for them to be useful. So, FAIR is an acronym standing for findable, accessible, interoperable, and reusable. So it just shows we need to think both about making the information available and then what are the standards, the guidelines, and so on for doing so in a thoughtful, effective way. Then, so here we move to an initiative that may not get as much attention, but then there's the pre-registration of studies. So before one actually engages in a study, actually registering somewhere, the fact that the study is going to be done and giving some information about how it's going to be done, ideally some information about the study design, and then ideally later on, putting forth some of the results there. And this has especially gotten attention in the biomedical context where there's legislation requiring this. And that's because of concerns about publication bias, or sometimes people will refer to the file drawer effect, where the thought would be, say you have a company that's producing a drug and they may do a lot of studies on it. Well, they have an incentive to publish and prominently advertise studies that made it look good. And then if there are studies that weren't so favorable, there's the temptation to just put it in the file drawer and not really emphasize it or make anybody aware of it. And even outside of those corporate contexts, we all know in science, you may do some studies that get some flashy, interesting results, and other studies that don't really show anything. And naturally, we're going to tend to publish the flashy, interesting results. But no matter how this happens, the worry is, the published literature may not adequately represent overall the information available because we're only publishing some of our studies. And so pre-registration is supposed to help address that one can see, okay, there were 20 studies undertaken here, but only 5 of them were published. And so we need to be careful in interpreting them. And I would note that this is also becoming an issue in psychology and some other areas where this piece by the Proceedings of the National Academy of Sciences, you'll see the first author is Brian Nosek. He's a pretty influential psychologist who's been pushing forward the open science movement in that context. And he's been really encouraging social scientists to be more likely to pre-register their studies because he's worried about the potential for slipping between exploratory studies and confirmatory studies, and sort of after the results are in, sort of then making some hypotheses that wouldn't actually be appropriate from a statistical perspective to do that. And one can call this hypothesizing after the results are known, or the acronym HARKing. And so he says that in order to address reproducibility issues, we really need to stop doing this. And he thinks pre-registration is one way to address that. Then I think this is a fascinating example of another open science initiative where some scientists are trying to sort of make their notebooks kind of open, if you will, so that others can see the studies they're planning to do and their ideas for the protocols, and they can provide feedback and so on before the studies even occur. And so I think this is fascinating because in some ways it illustrates what we might think of as the ideal scientific ethos, this openness, this community that's just all working together to do the best science possible. But you can also see that in the real world, there are some real barriers to this. There can be concerns about, being scooped, that, others are going to take one's ideas and move ahead with them, or, steal them and write grant proposals, ahead of you and so on. So I totally understand that, not everybody would be comfortable with this, but it's a fascinating kind of effort and project. And then at the peer review stage, there are ways of making that more open. And if you're interested in this, this is a really interesting paper, I think, that highlights a lot of different forms it can take. So, just a very minimal form would just, be making the peer reviewers known when the papers are published. But one can go a lot farther and actually, publish the review reports, even publish the responses to the review reports, and even extend the peer review so that others can then sort of, make comments in an organized way. And, you can imagine the benefits of this, being able to appreciate some of the strengths and weaknesses of a study methodologically from being able to see those review reports. So this is another interesting effort. And then, as I'm going to be discussing with opportunities, I really think it's interesting to think about how we can extend the relevance of open science beyond the scientific community. And so if we're trying to be open in a way that non-scientists can appreciate, one of the ways to do that is to get them involved in the research so they can see what's going on. And so I'm sure you all are probably familiar with the rise of citizen science. And I highly recommend this website. You can Google The Crowd and the Cloud, and it has a variety of vignettes, videos featuring different citizen science initiatives. The National Science Foundation in the US put this together, and I use it in my teaching. And they show the range of citizen science, from projects where the community members are pretty much just collecting data for the scientists or helping to analyze the data, all the way to efforts where the community members have really driven the research forward and are playing a significant role in even sort of interpreting and communicating the results. But my point here is that if citizens are involved in this way, it helps to then enables them to understand more of the methodology associated with the studies. And other initiatives like community-based participatory research, or various kinds of participatory action research also can link up researchers with community members. And thinking from kind of a toxicology perspective, I would just mention this as an interesting initiative. I don't know super well. What I liked was that it was an effort that brought together different stakeholders, industry that was producing, pesticides that were of potential concern to bees, as well as, stakeholders from government and those from, beekeepers and farmers and so on. And so by bringing these stakeholders together, hopefully it both produces better science and it enables those stakeholders to better appreciate the nature of the science, the methodologies, the results, and so on. And then I would point out, we've got all these initiatives that we can undertake, but this doesn't do a whole lot of good if people don't have the motivation to actually do it. And I totally understand, as I'm going to discuss in the barriers, it takes effort to do a lot of this. And so we need to consider, how do we incentivize people to actually undertake some of these things? And so funding agencies, universities can do things, but journals can as well. And so there are guidelines like the TOPS guidelines that have been developed for journals to encourage these activities. And this piece from Science a few years ago highlights these guidelines. And you can get a pretty good sense of them just by looking. I would note, by the way, Brian Nosek, again, is the first author here. And so if you look at this figure or table, you can see these 8 standards that involve different aspects of open science, if you will. So openness about data, openness about methods, pre-registration of studies, and so on. And it shows how journals can achieve different levels, if you will, with respect to these standards, where level 0 means they're not really requiring much of anything. And level 3 means they're being very stringent in requiring scientists to achieve this level of openness. And so these top lines can help journals think about the approaches they want to take. Okay, so with those initiatives discussed, let me turn now to some of the barriers that I think we need to think about as we move forward with open science. And so some of these are related to individual researchers. And as I collaborate with other scientists, I really see the fact that it can take extra time and money to, sort of have somebody putting data in a form that can be shared in a useful way. And some people also worry, say with pre-registration, that this could hinder scientists' spontaneity if they're having to specify so much in advance, what they're going to do in a study. And I think it's worth considering in the environmental scientists, in the environmental sciences, there is the worry about harassment, where open science could be kind of weaponized to attack researchers that are doing work that particular interest groups don't like. So we've seen this in the climate science arena, where groups who are skeptical of climate change will put in Freedom of Information Act requests to try to get all kinds of information from them about their emails and their data and so on. So it just slows the scientists down and can really mess up their research. So we need to keep that in mind, and I'm going to talk about this a little bit more in a moment. For society at large, there are legitimate worries that there can be misinterpretation of the information made available. My impression is that some of the big regulatory agencies, like the Food and Drug Administration in the US, they will say one of the reasons they don't want to make all their study data available is because they're worried that people will misinterpret the data and then spread a lot of misinformation. So that is a concern we have to acknowledge. The thought is the more information you provide available, it can cause confusion. It might even cause a false sense of security if people think, oh, these scientists are being very open and transparent, and not realize the methodology may still be pretty problematic. And then private companies, of course, have legitimate concerns about confidential business information. Some folks will point out that they may use this sometimes to block openness in cases where they really could be more open, but in some cases, I think it is a real concern. And then there are worries that for research participants, say studies that involve, human, health data, that it can be a problem to release that private information. And that leads into a really interesting example, I think, that you all may have followed, where the Environmental Protection Agency in the US under President Trump has developed this plan where they say they want to advance open science for the EPA so that any of the studies being used as a justification for regulations, they say the data underlying those studies needs to be publicly available. So this sounds great. It sounds like a good initiative, but a lot of people feel like it's really sort of sneakily weaponizing open science to block good environmental regulation, because a lot of the important studies that underlie regulations, say related to air pollution, these are based on a lot of human data, such that there are privacy concerns with making all that data available. Folks could potentially get information about people's health. And so there have been prominent editorials in major journals arguing that this is a problem and shouldn't be pursued. And the worry is that the Trump EPA is, again, just trying to say, well, if this data can't be made available, we can't rely on these studies for making regulations, and it could harm environmental regulations. So we need to think about those issues. Now, another just sort of perspective on these barriers. This is the one slide where I get to act a little bit more like a scientist and actually present some data. This was developed with some collaborators of mine, where we sent out a survey to a number of environmental scientists funded by the National Science Foundation. And we were asking about a lot of things, but one was related to barriers of data sharing. And we had a question on a Likert scale ranging from 1 to 5 of how significant a barrier are these various considerations. And what I found really fascinating, these are arrayed from the highest on the scale to the lowest. If you look at the top 3 items, the reasons people at least said they found it difficult to share data related to these issues of we don't have time, or we don't have money, or it's difficult to format the information. So then we got to concerns about being scooped and so on. So I think it highlights the fact that if we want to push open science, we need to provide the resources for scientists to be able to do this. So now I'd like to turn to the opportunities, which is where I'd like to talk about some of my own thoughts on how we can move open science forward in some fruitful ways. And so first, I think that we can make open science more broadly relevant to an array of stakeholders. And then I want to highlight the fact that a lot of stakeholders and community members really care most about what I call key judgments related to research. So not the underlying nitty-gritty data, but just the major judgments associated with the research that I'll clarify. And if we're going to achieve this, we need to develop systems and not just depend on individual scientists to be achieving this kind of openness that's meaningful to these different groups. So first, there's a commentary that I published last year with David Resnick, in which we argued that a lot of the initiatives for open science are most helpful for other members of the scientific community. And so if we want to be making open science really relevant to others, like regulators, policymakers, members of the public, we need to think about ways of achieving that. And our point was, for somebody like me, it does help me if underlying study data are available. I don't know what to do with them. And even just having access to published papers beyond paywalls, they're still often pretty difficult for most people to interpret. So we need to find ways to be open in ways that a range of people can make use of. And so we provided various examples in our paper. Here are just a few. So NASA, of course, has all kinds of data, and they can make them available, but that doesn't mean that most people can really use them. But there are these great initiatives, this HACCAST, Health and Air Quality Applied Sciences team. NASA put together a group of academic scientists who were willing to work with different stakeholder groups. Often these were like local cities that were concerned about air quality or other environmental issues. And so these scientists basically used the data in ways that were meaningful to these stakeholders. And again, another project where NASA worked with USAID. So this involved efforts around the world where you might have local governments that were concerned about flooding or other environmental effects. And so these scientists help them to make use of this data. So it's a kind of openness that's actually useful for the particular needs these communities had. And you know, climate services, I think, provide another example of this. We're familiar with weather services that provide information about weather. Well, now there's this rise of climate services, often private companies that will, you know, sort of provide information about climate for local communities. And the thought is they can take the information that's available and actually interpret it and use it to provide meaningful information for these communities. So I'd like to think about how we can do more of this. Another example from kind of a toxicology context, Bayer, as they've recognized that Europe is pushing toward making companies make the safety study available for their pesticides, they have a website now where they try to provide some background information so that maybe this data can be more useful to a broader range of communities. I haven't looked in detail at this website. You know, I don't know how far it actually goes, but I think the idea is a really cool one. Okay, so my next point is, if we want to make open science relevant to different communities, I think most of them don't care as much about the details of the data, but about what philosophers of science call key judgments in science. So these could be choices about, you know, how studies are designed or analyzed, the background assumptions that affect how the studies are interpreted, various aspects of how the studies are framed. So in other words, you know, if I, as sort of a layperson, hear about a study, I really care about what are the key strengths and weaknesses. How does the study compare with the research that's gone before? What are the big holes that, you know, some further studies need to fill? I think that's the kind of information most people want to know. And so, but that kind of transparency, that kind of openness, I think we can't just depend on individual scientists to provide, because different communities care about different judgments, and the scientists doing the study may not even be aware of key weaknesses or key ways they're framing their findings that may be problematic. And so regulatory agencies can provide a role in highlighting these kinds of judgments. And I think non-governmental organizations and the media can play an important role, where, say, scientists associated with an NGO can interpret, if you will, new studies in ways that matter to people associated with that NGO. And for the media, I have this paper that I published last year exploring how, given the goals and the skills of the media, they can, I think, play a really valuable role in taking studies and highlighting the judgments that matter for the broader public. So I think we should think of them as part of the open science movement, actually. And so if we're thinking about these broader systems of, you know, people beyond the scientific community being part of open science, I think we want to ask a range of questions. So we want to ask, you know, what's our goals here? Are we actually trying to be open in a way that's useful to particular communities beyond scientists or, you know, beyond policymakers? And so then we can consider, well, then who is our audience if that's our goal? And what's the content that matters to them? Do they care about the data? Do they care about the publications? Do they care about some of these judgments? And so then who are the actors that can make this information available? Is it the media? Is it the NGOs? Is it a scientific society? And what are the venues for making this information available? And how do our efforts need to change given the dangers that may be present, or the that we need to consider of a certain kind of openness? So now we come to, this is my second to last slide, my last slide before the conclusion. The vision that I'd like to leave you with is that ideally, I think open science can promote this concept that I just started hearing recently, the idea of a collective science capacity, that we can have this capacity distributed beyond just scientists, but among policymakers, companies, communities, to know scientific information, to contribute to research, to be able to communicate about science with each other and evaluate and ultimately make use of it. And so the thought is open science, as I'm suggesting, can ideally help this community to be using science and making good decisions with it. And then if we have this extended community with this capacity, that can make open science more effective. Because like I was saying, then if you have the capacity within NGOs, within the media, within other community members to be talking about science in ways that are meaningful to those around them, well, that can make science more open in effective ways. So again, just to wrap up, I've tried to highlight these major themes in the open science movement. I've tried to highlight these 3 opportunities that I think we can be thinking about: how to be relevant to different actors, how to be open about key judgments that matter to them, and trying to think through broader systems for achieving these goals. And I did have that one slide with data, so that work was funded by the National Science Foundation, and these are my collaborators, so I'd like to acknowledge them. So I'll stop there, and I'd love to have a discussion with all of you.
Thank you so much, Mr. Elliott. That was great. It's very different than what we had previously in the other webinars, but I say that in a positive way, so it's good. You had 2 questions from Laurie in the chat, but she told me in the private chat that you answered it a bit after about the public organization influence on the development of the application of good open science practice. So if people have any other question, you can ask it in the chat, or you can ask if you want us to open the mic. Meanwhile, I had a question, like you mentioned it quickly at the beginning, but from your observation, do you think the changes in science brought by the COVID-19 crisis are positive or not?
Yeah, well, so that's a question that I can say a few things, but I think you all as scientists are probably just as equipped or better equipped than I am. I think overall these movements toward open science are valuable in terms of achieving the objectives I mentioned earlier. So I think that pushing to make more data openly available and sharing, I think, is very effective. I think that the flood of preprints does highlight those concerns I mentioned. And so ideally, it will help move forward thinking about how to make these preprint servers as responsible as possible. So like some of them I know, like I think the preprint server for medicine has more stringent requirements before they put up preprints than some of the other servers. And there may be ways to actually combine the preprint servers with a more open peer review, so that you can have peer review comments on them to help highlight the strengths and weaknesses. And I haven't been able to keep up on how prevalent that is with these servers. You all may be able to sort of help educate me on that. But I think that COVID-19 overall has been positive, but it also highlights concerns that we need to be addressing.
Thank you. Another question in the chat is, do you know the website pubpeer.com? And if you can comment on it, if you do know it.
Yeah, so, I've heard just a little. I don't feel like I know it well. Is that one of the sites where you can kind of get credit for peer reviewing activities, perhaps? Because, that is an initiative with peer reviewing. I think, so let me just acknowledge, I don't know a lot about that. You all can feel free to tell me more. But I do think that these issues of open peer review, it gets tricky because I acknowledge I would be more cautious about engaging in peer review, or if I know my reviews are going to be openly available, just knowing my name is going to be out there, makes me a little bit more cautious. But one might say that's a good thing. We need peer reviewers to do a better job, and it might make the whole peer review process better if we did more of that. So those are just a few thoughts related to peer review.
Very interesting, thank you. And Sébastien Sauvé first asked if, I know the webinar is recorded and will be available on YouTube, but can you also provide the presentation at a PDF format? Can you do that?
Yeah, I would be willing to do that. I assume I can talk to the organizers to figure out if I make it available to them, they can provide it to other people who would be interested, perhaps.
Absolutely. We wouldn't
Yeah.
send it to everybody, but we can receive it. And anybody who would like to have a copy would just have to email us, and we'll be gladly sending it to them. I guess that's in line with your open science strategy, eh?
That's right. That would be a little hypocritical if I said, no, you cannot have access to it.
True. Thank you, Patrice. And Sébastien Sauvé would like to open his mic to ask you a question about strategy. So you can go on, Sébastien.
Thank you for the nice seminar. What do you think is the best strategy to convince the granting agencies in North America to move towards a more strict open science publication policy like they do in Europe?
Wow, that is a tricky question. I wish I had a better, more sophisticated answer. And I would actually be very curious to hear from you all as practicing scientists. The feel I would have is that the funding agencies would probably be pretty supportive, but they're probably worried, I think, about the barriers associated with others, say, and I assume you were asking partly about the open access publications, like the Plan S. So I think that, the worries people raise, of course, is that you can have smaller scholarly societies, publishing journals where this could really mess up their, funding model and so on. So again, feel free to correct me, and I could open this up for a discussion, but my sense is I think the funding agencies would be very supportive. They're worried about the challenges with the journals, scholarly societies, academics pushing back and so on. But I'd love to hear your thoughts.
Great, thank you. And Laurie asked, I got a private question in the chat. Do you think the open science wave that we see right now will change the way we manage patents?
That is such an interesting question. And I really should, I appreciate that question. I should include that in the in future presentations. So I'm kind of skeptical that this will change patent policy because there's so much lobbying and money at stake in that context, where, in some of my teaching, I'm not an expert on patent policy by any means, but it just seems like there are such incentives in the private sector to and so much momentum for keeping that intellectual property protection in place that I don't see us being able to change that very easily. And if anything, the feel I get is that we've moved gradually toward more and more stringent patent protection, being able to patent, genetically modified organisms and so on. There was a Supreme Court case in the US, you all may be familiar with the Myriad Genetics case, where the Supreme Court did back off a little bit on some of the genetic patenting in the past 10 years, but I think it'll be very difficult to extend these principles of open science to patenting.
Thank you. When you showed that the main problem to open science was time, do you think we should switch to quality rather than quantity?
Yeah, great question. This same discussion comes up in conversations about the concerns about the reproducibility crisis. If you all wanted just an interesting, accessible book on that issue, I really recommend a book I've used in some of my teaching called Rigor Mortis. It's kind of a clever title with the idea of, sort of losing your rigor is dying. But it's by Richard Harris, who's a reporter for National Public Radio in the US. And he basically discusses the reproducibility crisis in biomedical research and psychology research. And he discusses the arguments for slowing down science, making it of higher quality, and but he also discusses the significant barriers to achieving this. The fact that you have so many incentives on scientists to need to publish or perish and churn out grant applications and so on. So I just think the overall context in which scientists operate makes that really difficult. And so we would need to think about how to alter that incentive system. And universities would have to change I think their approach to evaluating people for tenure and promotion to focus on a few really good studies as opposed to quantity of studies and so on. And one other thing I would just point out, even without changing all those complex incentive systems, you know, just as part of funding applications, providing money for, you know, a grad student or a postdoc or somebody to focus on that, getting data into shape. You know, that's another way to approach this, but then you're taking money from some purposes and potentially putting it toward that. So we need to think through our priorities, I think.
Right, just so you know, I put in the chat the whole name of the book with the name of the author that you just talked about. And now Patrice has a question for you.
Yes, indeed. My question is one that I've been wondering for a long time with open publishing. It's about the cost of publishing and the fact that what I see in my field is that very often only the wealthy labs can actually publish open access. And so you know, and most of the researchers just can't afford spending $2,000, $3,000, $4,000 for one publication. So that basically skews the information that is available in open access towards those labs that have money. What do you think is the impact of that on access to research?
Yeah, I mean, so I wish I had, you all raised such good questions. I wish I had better answers, but I'm very sympathetic to that concern because in the humanities, you know, we're typically operating without research grants. And so we definitely don't have money to pay those kinds of open access fees. And so I think we need to think not just about, you know, the more well-off labs that have a lot of money from grants, but also across disciplines and how this will affect different so these policies. So I guess that's just accentuating your concerns, but it doesn't really answer your deeper questions about what all the effects might be. I think if we really are wanting to move this way, I think funding agencies, those creating these policies, have to be thinking about these downstream effects and how to address them. I'm not totally sure what to do about that. Maybe one thought that occurs to me, actually, I'll go ahead and say one thing that you all may already know, but maybe we need to think about this in a more systemic way where the money that is currently going into, say, like university libraries, purchasing access to all these journals, maybe, you know, we need to shift that money into, you know, sort of funding so that, you know, all the researchers at a university can just standardly publish their work open access. So you all probably know more than me about those negotiations in places like Europe, but I think we need to really think about the whole system and not just say, hey, you all just have to find the money to publish your work open access.
Yeah, great. I hadn't thought of that. It's really it's like different fields involve different challenges for access. Yeah. Indeed.
Yeah.
Mm. Thank you. So I will go with one last question and then Patrice, you can do the last word. It's a bit more personal. It's not directly related to what you talked about, but I was curious to know, like, what is your official job or what do you do on a daily basis?
Yeah, you know, that reminds me, my mother-in-law asked me when I say I'm doing research, she says, you're not collecting data. How can you do research? Yeah, so it's really interesting being a scholar as a philosopher. So of course, you know, like most other academic faculty, you know, I have my courses that I'm teaching, but then when I'm doing my research, it involves much more kind of conceptual work. So I think the closest thing that you can probably relate to is if scientists are writing like opinion pieces. It's like I'm spending all my time writing big, hopefully really thoughtful opinion pieces where, you know, we're sort of trying to synthesize information to, you know, ask questions. Like my big research area is the role of values in science. So trying to think through, well, you know, what are the ways in which ethical and social values can impact science? And when do we think that's appropriate? and under what conditions do we think that's inappropriate? So trying to really carefully think about this. So it's not so much a purely empirical question, but this conceptual question, a more normative question. So that's, I don't know if that helps to answer your question. So I spend lots of time sitting around thinking, contemplating, writing, thinking, what are the objections to this? You know, how can I respond to them? You know, that sort of thing. So that's the life of a philosopher.
Thank you very much. It was a very, very interesting seminar. And first of all, I also want to thank Isbat for organizing the seminar, Lou for animating the questions period, and of course you, Kevin, for this great presentation. I didn't tell you, but I happen to be in charge of a course at INRS called Ethics and Communication, and it's based on it's basically a course about the relationship between how you communicate science and how you can do it ethically with conflicts of interest and plagiarism and all these kinds of issues are covered as well. So your webinar is very inspiring and will certainly contribute to improve my own course. So thank you very much. As we have already mentioned, your webinar will be available on our YouTube channel shortly. So thank you, everybody. Thank you a lot, Kevin, and see you soon.
Thank you all so much for tuning in to hear a philosopher. I appreciate it.
It was a great pleasure.
Yeah, you're more than welcome. We are thanking you.
Bye-bye.
All righty, goodbye. All right. So you don't need any more information from me? Are we all good?
No, it was really, really interesting. Really, it's very, very, let's say, nice to kind of be able to think outside the box of the usual. We usually don't discuss these things very, very simply. We just get bothered by, oh, okay, well, we have this funding agency is insisting that we publish open, but we don't give us funds to do it. So how are we going to do it? And we just try to kind of, you know, address the concerns and not think about the implications. But it's nice that you're doing it.
It's
much
great.
appreciated.
Well, thank you. Alrighty. Well, then I think unless any of the folks here are wanting to talk more, I'll sign off because I actually need to teach in a few minutes. So,
okay.
all right.
Have a good
Very good.
course.
Thank
Thank
you.
you. Bye.